Hello friends, today we are going to start the topic infrastructure as a service model. In this, we are going to learn about infrastructure as a service model, architecture, advantages, disadvantages, etc. Infrastructure as a service. Infrastructure as a service is a service model, is the original service model or one of the original service model amongst the cloud service models. Infrastructure as a service is a form of cloud computing that provides virtualized computing resources over internet. Infrastructure as a service is one of the three main categories of cloud computing services alongside software as a service and platform as a service. Infrastructure as a service is an instant computing infrastructure provisioned and managed over the internet. It is one of the four types of cloud services along the software as a service, platform as a service, and serverless. IaaS or infrastructure as a service quickly scales up and down with the demand, letting you pay only for what you use or what we use. It helps us avoid the expense and complexity of buying and managing your own physical servers and other data center infrastructures. Each resource is offered as a separate service component, and you only need to rent a particular one for as long as you need it. A cloud computing service provider such as Azure manages the infrastructure while you purchase, install, configure, and manage your own software operating systems, middleware, and applications. In an infrastructure as a service model, a cloud provider hosts the infrastructure components traditionally present in an on-premises data centers, including servers, storage, and networking hardware, as well as the virtualization or hypervisor layer. It is actually the starting or introduction of the architecture and how it works. Now, this IaaS, or you can say infrastructure as a service provider, also supplies a range of services to accompany those infrastructure components. These can include detailed billing, monitoring, log access, security, load balancing, and clustering, as well as storage resiliency such as backup, replication, and recovery. Now, this storage resiliency, it contains of three major things. These three major things are backup, replication, and recovery. What is backup? Backup we usually do of our data. Like we used to restore our data or we used to keep our data to one or more places so that when we need it and if one of the devices is not working, we can still extract that particular information or data from that backup. So this thing is helped by infrastructure as a service as it maintains this backup part. Next is the replication. In replication, what we do is we mirror the particular data. Now, mirroring of data means we are copying that particular data or we are having its mirror image to another data centers or another storage spaces where our data is safe. In case of any catastrophe, if you are not able to recover your data, then also the data is not lost. If a particular server or a particular site is not working, then also I can access that data with the help of this replication. And next is the recovery. Recovery means in case of any disaster, if any physical calamity occurs for that particular data center and it is completely destroyed, still my data is safe and I can recover it. So for that also, this particular infrastructure as a service, it provides this particular service or feature also. Next point is, these services are increasingly policy driven, enabling infrastructure as a service users to implement great levels of automation and orchestration for important infrastructure tasks. See, now infrastructure as a services, these services are policy driven. That means whatever the policy is being there implemented, the particular infrastructure as a service model will work as per that policy only or that policy guidelines only. Then it enable or infrastructure as a service enabling users to implement. What does it enable users to implement? That is greater levels of automation. That is the automation which we want in particular industry is done, or you can enable it more efficiently with the help of this infrastructure as a service and orchestration for important infrastructure tasks. Now, for example, a user can implement policies to drive load balancing to maintain application availability and performance. Infrastructure as a service customers access resources and services through a wide area network, or we can say the WAN, such as the internet, and can use cloud provider services to install the remaining elements of an application stack. For example, the user can log into infrastructure as a service platform to create virtual machines, install operating systems in each virtual machine, deploy middleware such as databases. It can create storage buckets for workloads and backups and install enterprise workload into that virtual machine. Now, this virtual machine will act like a physical machine to the user or a particular desktop to the user. What user will do with the help of infrastructure as a service? It can go there and then it installs the operating system. Installing operating system helps the particular user to work or access that infrastructure directly. With that, in each virtual machine, if you're doing it, creating multiple virtual machines, installing operating systems into that virtual machines, accessing it as a physical machine. That means from a single server or single infrastructure, many virtual machines or many users can access that particular thing at a time. This is multi-tenancy. And then they can deploy the middleware. They can also create these storage buckets for workloads and backups, and then enterprise workload into that virtual machine. Customers can then use provider services to track costs, monitor performances, balance network traffic, troubleshoot application issues, manage disaster recovery, and more. Any cloud computing model requires participation of a provider. The provider is often a third party organization that specializes in selling infrastructure as a service. Amazon Web Services, AWS, commonly known as Google Cloud Platform GCP, are examples of independent infrastructure as a service providers. A business might also opt to deploy a private cloud, becoming its own provider of infrastructure services. Infrastructure as a service is made up of collection of physical and virtualized resources that provide consumers with the basic building blocks needed to run applications and workloads in the cloud. Now, this is the platform and architecture for infrastructure as a service. So in platform and architecture, we again see this point. It is made up of collection of physical and virtual resources. Now, collection of physical and virtual resources, physical resources which make a particular infrastructure, and virtual resources are responsible to connect them and also provide it to the multiple users, which provide consumers with basic building blocks, okay, and needed to run applications and workloads in the cloud. First point is physical data center. In infrastructure, platform, and architecture, the first thing we are going to know is physical data centers. Infrastructure as a service providers will manage large data centers typically around the world that contain the physical machines required to power the various layers of abstraction on top of them and that are made available to end users over the web. In most IaaS models, that is infrastructure as a service models, end users do not interact directly with the physical infrastructure, but it is provided as a service to them. See, we use Google services. Google do not provide or we do not have anything to do with the physical infrastructure of the Google, but we use Gmail services. So service or software as a service, that particular service of that infrastructure is provided to us. Now what we need is we require is the Gmail service, so we use that particular service which is provided, but I need not to know about the physical infrastructure through which that particular Gmail service is provided to me. This sentence explains that. Second point is compute. In compute, infrastructure as a service is typically understood as virtualized compute resources. So, for the purpose of this article, we'll define infrastructure as a service compute as a virtual machine. Providers manage the hypervisors and end users can then programmatically provision virtual instances with desired amounts of compute and memory, sometimes the storage. Most providers offers both CPUs, that is central processing units, and GPUs for the different types of workloads. Cloud compute also typically comes paired with supporting services like auto scaling, that means as per the demand that particular requirement can be increased and decreased, and load balancing that provide the scale and performance characteristics that make cloud desirable in the first place. Next point is network. In networking in the cloud is a form of software defined networking in which traditional networking hardware such as routers and switches are made available programmatically, typically through APIs. APIs is application programming interfaces. More advanced networking use cases involve the construction of multi zone regions and virtual private clouds, both of which will be discussed later. Next point is storage. The three primary types of cloud storage are block storage, file storage, and object storage. Block and file storage are common in traditional data centers but can often struggle with scale, performance, and distributed characteristics of cloud. Thus, of the three, object storage has thus become most common mode of storage in the cloud, given that it is highly distributed and thus resilient. It leverages commodity hardware. Data can be accessed easily over HTTP with object storage, And scale is not only essentially limitless, but performance scales linearly as the cluster grows. Data centers, availability zones, and regions is the next point. To promote greater availability and resiliency of resources, most cloud providers today offer a hierarchy around how workloads map to physical and virtual infrastructure as well as geography. As an example, IBM Cloud has availability zones and regions. These two terms are defined as follows. What is cloud region? See, for IBM, we are going to learn about IBM Cloud region. A region is a geographically and physically separate group of one or more availability zone with independent electrical and network infrastructures isolated from other regions. Regions are designed to remove shared single points of failure with other regions and guarantee low interzone latency with the region or within the region. Now, next, what is availability zone? An availability zone is a logically and physically isolated location within that particular region or that particular cloud region with independent powers, cooling, and network infrastructures isolated from other zones. This strengthens fault tolerance by avoiding single points of failure between zones while also guaranteeing high bandwidth and low interzone latency within that particular region. Organizations choose infrastructure as a service because it is often easier, faster, and more cost efficient to operate a workload without having to buy, manage, and support the underlying infrastructure. With infrastructure as a service, a business can simply rent or lease that infrastructure for another businesses. Infrastructure as a service is an effective model for workloads that are temporary, experimental, or that can change unexpectedly. For example, if a business is developing a new software product, it might be more cost effective to host and test the application using an infrastructure as a service provider. Once the new software is tested and refined, the business can remove it from infrastructure as a service environment for a more traditional in house deployment. Conversely, the business could commit that piece of software to a long term infrastructure as a service deployment, where the cost of a long term commitment may be less. In general, infrastructure as a service customers pay on a pay per use basis, typically by hour, week, or month. Some infrastructure as a service providers also charge customers based on the amount of virtual machine space they use. This pay as you go model eliminates the capital expense of deploying in house hardware and software. Thus, it is cost effective or you can say cost efficient. When a business cannot use third party providers, a private cloud built on premises can still offer the control and scalability of infrastructure as a service, though the cost benefits no longer apply to it. Despite its flexible pay as you go model, infrastructure as a service billing can be problem for some businesses. Cloud billing is extremely granular and it is broken out to reflect the precise usage of services. It is common for users to experience sticker shock or finding costs to be higher than expected when reviewing the bills for every resource and service involved in an application deployment. Next point is users should monitor their infrastructure as a service environments and bills closely to understand how infrastructure as a service is being used and to avoid being charged for unauthorized services. Insight is another common problem for infrastructure as a service users because infrastructure as a service providers own the infrastructure. The details of their infrastructure configuration and performance are rarely transparent to infrastructure as a service users. This lack of transparency can make systems management and monitoring more difficult for users. Infrastructure as a service users are also concerned about service resilience. The workload's availability and performance is highly dependent on the provider. If an infrastructure as a service provider experiences network bottlenecks or any form of internal or external downtime, the user's workloads will be affected. In addition, because infrastructure as a service is a multi tenant architecture, the noisy neighbor issue can negatively impact users' workload. Now we come again discussing the advantages of infrastructure as a service. So, infrastructure as a service, it eliminates capital expense and reducing ongoing cost, as we have discussed earlier also. Infrastructure as a service sidesteps the upfront expense of setting up and managing an on site data center. That means we are renting out something. For example, if I want to live in a house in a particular city, but I don't know how much for how long I am there. So, what to do instead of buying a house in that particular city, that is my capital expense there. I am renting a particular house for certain duration. That fixed amount of money I have to give to the owner, and I can use or access that particular service, or that I can have that house as mine for that particular time or duration. So this is what infrastructure as a service is providing to the companies. What do they do? Instead of the capital expense of creating their on-site data premise, they rent the pre-existing infrastructure from infrastructure as a service providers, making it an economical option for startups and business testing new ideas. It improves business continuity and disaster recovery. How? Achieving high availability, business continuity, and disaster recovery is expensive since it requires a significant amount of technology and staff. But the right SLA, that is service level agreement, in place, infrastructure can reduce this cost and access applications and data as usual during a disaster or outage. Innovate rapidly. Infrastructure as a services, they innovate rapidly or frequently. Like as soon as you have decided to launch a new product or initiative, the necessary computing infrastructure can be ready in minutes or hours rather than the days or weeks and sometimes months it could take to set up internally. It responds quickly to shifting business conditions. Infrastructure as a service enables you to quickly scale up resources to accommodate spikes in demand for the applications during holidays. For example, then scale resources back down again when activity decreases to save money. Next is focus on your core business. Infrastructure as a service frees up your team to focus on your organization's core business rather than on IT infrastructure. It increases stability, reliability, and supportability is the next advantage. With infrastructure as a service, there is no need to maintain and upgrade software and hardware or troubleshoot equipment problems. With the appropriate agreement in place, the service provider assures that your infrastructure is reliable and meets service level agreements. It provides better security. With the appropriate service agreement, a cloud service provider can provide security for the applications and data that may be better than what you can attain in house. It gets new app to users faster because you don't need to first set up the infrastructure before you develop or deliver apps. You can get them user or you can get them faster to the users. Typical things businesses do with infrastructure as a service include: first thing is test and development. Teams can quickly set up and dismantle test and development environments, bringing new applications to the market faster. Infrastructure as a service makes it quick and economical to scale up development test environments up and down. These were the common business scenarios of infrastructure as a service. First first point we have discussed already. This is the second point, that is website hosting. Now, running websites using infrastructure as a service can be less expensive than traditional web hosting. Next comes storage, backup, and recovery. We have been discussed about these things a lot. Now, organizations avoid capital outlay for storage and complexity of storage management, which typically requires a skilled staff to manage data and meet legal and compliance requirements. Infrastructure as a service is useful for handling unpredictable demand and steadily growing storage needs. It can also simplify planning and management of backup and recovery systems. Next is the web apps or web applications. Infrastructure as a service provides all the infrastructure to support web applications, including storage, web and application servers, and networking resources. Organizations can quickly deploy web apps on infrastructure as a service and easily scale infrastructure up and down when demand for the applications is unpredictable. Then comes high performance computing. High performance computing, or also known as HPC, on supercomputers, computer grids, or computer clusters helps solve complex problems involving millions of variables or calculations. Examples include earthquake and protein folding simulations, climate and weather predictions, financial modeling, and evolution product or evaluating product designs. Next point is big data analytics. Now, big data is a popular term for massive data sets that contain potentially valuable patterns, trends, and associations. Mining data sets to locate or tease out these hidden patterns requires a huge amount of processing power, which infrastructure as a service economically provides. Major infrastructure as a service vendors and products. There are many examples of infrastructure as a service vendors and products. AWS, that is Amazon Web Services, offers storage services such as simple storage services, also known as S3, and Glacier, as well as compute services including Elastic Compute Cloud or EC2. Then GCP, that is Google Cloud Platform, offers storage and compute services through Google Compute Engine, that is GCE, as does Microsoft Azure. These are just a tiny sample of broad range of services offered by major infrastructure as a service providers. Services can include serverless functions such as AWS Lambda, Azure functions, and Google Cloud functions, database access, big data compute environments, monitoring, logging, and more. Next is there are also many other smaller or more niche players in infrastructure as a service marketplace, including Rackspace Managed Cloud, CenturyLink Cloud, DigitalOcean, and more. Users will need to carefully consider the services, reliability, and costs before choosing a provider, and be ready to select an alternate provider and to redeploy to alternate infrastructure if necessary. Infrastructure as a service, commonly referred to as IaaS, is a form of cloud computing that delivers fundamental compute, network, and storage resources to consumers on demand, over the internet, and on a pay as you go basis. Infrastructure as a service enables end users to scale and shrink resources on as needed basis, reducing the need for high upfront capital expenditures or unnecessary owned infrastructure, especially in the case of spiky workloads. In contrast to platform as a service and software as a service, even newer computing models like containers and serverless, infrastructure as a service provides lowest level control of resources in the cloud. Infrastructure as a service emerged as a popular computing model in the early 2010s, and since that time it has become the standard abstraction model for many types of workloads. However, with the advent of new technologies such as containers and serverless, the related rise of microservice application pattern, infrastructure as a service remains foundational but is in a more crowded field than ever. Now, that this is the traditional IT. Here is one diagram which shows the traditional IT, infrastructure as a service, platform as a service, and software as a service. Here, the one vendor managed and user managed. In traditional IT, from networking to application, all these things were user managed. But in infrastructure as a service, networking, storage, servers, and virtualization. These four are vendor managed, and operating system, middleware, runtime, data, and application. These are user managed. For platform as a service, networking, storage, servers, virtualization, operating system, middleware, and runtime. These are vendor managed. And applications and data, this is user managed. Then, in software as a service, from networking to application, everything is vendor managed. Infrastructure as a service versus containers versus serverless. More recently, the discussion around cloud workloads has become increasingly dominated by containers and serverless. In many ways, infrastructure as a service was a step in the journey to the Platonic idea of cloud. Infrastructure as a service does offer end users much more granularity to pay for what they use, but they rarely pay only for what they use. Even virtual servers often involve long running processes and less than perfect capacity utilization. Infrastructure as a service abstracts away many low level components so developers can focus on business logic that differentiates the business. But it does still require end users to manage operating systems, middleware, and runtimes. Infrastructure as a service often more resource and financially efficient than traditional compute, but spinning up a virtual machine can still be somewhat time consuming, and each virtual machine brings with it overhead in the form of operating systems. This model of IT was capable of supporting at most or almost anything from a workload perspective, but had room for evaluation when it came to certain underlying philosophies and values that make cloud. Containers and serverless are two newer cloud models that are challenging the traditional infrastructure as a service model for supremacy around certain classes of cloud native applications and workloads. In some cases, container has begun replacing the virtual machines as the standard unit of processes or service deployment, with orchestration tools like Kubernetes governing the entire ecosystem of clusters. Serverless got the farthest of any model, abstracting away nearly everything, but the business logic scaling perfectly with the demand and really delivering on the promise of paying only what you use. As the world moves forward or more towards microservices architectures where applications are decomposed to their small piece parts, deployed independently, manage their own data, and communicate via API, that is, application programming interfaces, containers, and serverless approaches will only become more common. Today, traditional infrastructure as a service is by far the most mature compute model in cloud computing, or we can say in cloud and controls. It controls the vast majority of market share in this space, but containers and serverless will be technologies to watch and begin employing opportunistically where it makes sense. Pricing. The next point. Infrastructure as a service is typically priced on consumption basis, meaning users only charged for what they use. Over time, the pricing models of cloud infrastructure have come to this span many different levels of granularity. Next is subscriptions and reserved instances. Now, in pricing, we see many providers offer discounts of the sticker price for clients willing to commit to longer contract terms, typically around 1 to 3 years. Next in pricing is monthly billing. Monthly billing models are most common in BMAAS market, where physical infrastructure typically implies steady state workloads without spiky characteristics. Next pricing condition, or we can say next thing by which we can do pricing, is by the hour or per second. The most common granularity for traditional cloud infrastructure, end users are charged only for what they use. Then other point is transient or spot. Some providers will offer up unused capacity at a discount via transient or spot instances. But those instances can be reclaimed if the capacity is needed. Virtual cloud or virtual private cloud and infrastructure as a service. For many end users, particularly companies with sensitive data or strict compliance requirements, additional security and privacy within a public cloud is a desirable. A virtual private cloud VPC can be a way of creating additional isolation of cloud infrastructure resources without sacrificing speed, scale, or functionality. VPCs, that is virtual private clouds, enable end users to create a private network for a single tenant in a public cloud. They give users control of subnet creation, IP address range selection, virtual firewalls, security groups, network ACLs, site to site virtual private networks, and load balancing. Infrastructure as a service is a service model that delivers computer infrastructure on an outsourced basis to support enterprise operations. Typically, infrastructure as a service provides hardware, storage, servers, and data center space or network components. It may also include software. Infrastructure as a service is also known as hardware as a service. An infrastructure as a service provider provides policy based services and is responsible for housing, operating, and maintaining the equipments it provides to the client or it provides for a client. Clients usually pay on per use or utility computing basis. The automated administrative task, dynamic scaling, platform virtualization, internet connectivity are some of the other points. Infrastructure as a service is also described as one of the three main categories of cloud computing services. The other two are software as a service and platform as a service. Thanks for watching this video. Stay tuned to Ekeeda. Subscribe to Ekeeda.